So hello everyone and welcome. This is our sixth lesson um, on collections and inheritance in our introductory Java series. Um, Last week we went over objects. Um, Real quick, Catherine, were you able to do the homework? Oh, great. Did you have any problems with it? Okay, cool. That works. Okay, great. So, are you okay if we skip over reviewing the homework? Okay, great. So let's go ahead and get started with and I've been talking with Yuhi, so we've already gone over things. So all right, let's get started. Um, Today we are going to be very busy. We will go over arrays, inheritance, polymorphism, casting, lists, array lists, map, and hash map. The first half is going to be a lot of information, and then towards the end is kind of more basic information and is stuff that you'll just need to practice. The first half is where most of the learning will happen. So this looks scary because I think this is the most we have covered in one class, but I promise you it won't be too scary. So any questions before we begin? Cool. All right, let's get started. So what are arrays? Arrays, to put it very simply, are ways to store multiple items of data in one variable. Um, More specifically, in Java, an array, all of the items that you store in the array must be the same data type. So like any variable in Java, you must declare the data type like int or boolean or char, momomo, or char, however you prefer to say it. Um, and arrays are the same. They only store one type of variable or one type of data. Um, Now we've learned about declaring variables in the past. You just do the data type followed by the name of the variable. Um, Arrays look very similar. The only difference is that after the data type, you put square brackets, which you can, let me turn on my pointer here, which you can see here. Okay. And that allows us to store many integer values into this myIntegers variable. Um, Now, if you remember, when we've been doing our main functions previously, we've been doing the string and then square brackets. That's just an array of string objects. So we've already been using arrays. We just haven't really talked about it. So now this is the second to last part of public static void main string args that you will be learning. Static is the only part that we have not gone over yet, and we will go over that in our second to last class. So I believe 2 more classes after this. But string, this is an array of strings as an input argument. This is an array of integers. Okay. Now, again, this is declaration here, right? Similar to variable declaration we have done in the past. And this is initialization, but there are 2 ways to do it. Well, technically there's more, but these are 2 of the main ways to do initialization of arrays. So this first way creates an array with a capacity of 3 items. This array can hold 3 items. That's why we put this 3 in square brackets. And we do new, the data type, square brackets, and then the number of items we can fit. This creates a new array that we can store into our variable. Um, in this case, when we do it this way, we have the array of 3 items. They will have a default value. Okay, so the default value for an integer is 0. So we'll have an array of 3 zeros in this case. Now, this is the capacity of the array. The array holds 3 items, and that cannot change. You cannot add a 4th item. You cannot remove any of the items. You can change the value. So you can change the 0 to a 1 or to a 437 or whatever. But the number of items, the total count of items in the array cannot change. Okay, they are fixed size. And as I mentioned, they'll use the default value. In the case of an integer, the default value is 0. So this will be an array of zeros. However, if we already know the values that we want to store, we can set the values ourselves using these curly brackets here. And this sets the array to be an array of 40, 21, and 657 as its 3 values. Same size as the other one, just with predefined values. Any questions about this so far? Cool. All right. Yuhi, you okay? All right. She's in the other room with me, so if she doesn't talk and I respond to her, it's because I can hear her. Okay. So I mentioned earlier, arrays are fixed size. You cannot add or remove values. So what if you want to get something out of an array? So you have this array of 3 items. What if you want to use one of the items? In this case, we use the square brackets again. So here I have an example of both declaring and initializing an array, okay, doing both in one step, as we've done before with other variables. And if I want to access the second value in the array, so if I want to access the 6 here, what I do is I give the variable name, followed by square brackets, and in the square brackets I put a 1. Now this is going to be a bit confusing. I'm accessing the second value here, but I'm giving it the number 1. Okay, this is the position, this is the which spot in the array that I want to get data from. But if I'm accessing the second value, why am I giving it 1? This is something that causes a lot of problems for new programmers, so focus on this a lot. In programming, we start counting at 0. So the first item, this 3, is actually the 0th item. Okay, so this is 0, this is 1, and this is 2. Okay, so if we do myInts square brackets 1, and we print this, it will say second value in myInts colon 6, because 0, 1. 1 is the 6. Okay, does that make sense to everyone? Cool, all right. So that's how to get values from the array. If you want to change the value in the array, if you want to set it, you again do the variable name, again do square brackets, and the position, and then you just use equals, the set operator, to set it to whatever value you want. Now again, because this is an array of integers, it has to be an integer value, but that's no different from any other variable. And then if we print this again, this would print the number 50. Okay? Any questions about getting or setting values in arrays? Cool. So far, so good. Now, what if you want to go through every item in the array, right? One of the reasons we have arrays is so that we can treat all of the items the same, right? Just like we've learned in the past, we can use a for loop. Array variables have a special property called length. So if you do numbers dot length, that will give you how many items are in the array. 1, 2, 3, 4, 5, 6, 7. So in this case, this would be 7. Okay. So in programming, we start counting at 0. So we start our loop at 0 for I, and then as long as I is less than 7, it will continue. And then at the end of each iteration, it will increase I by 1. This is the same as loops we have done in the past. So this will print number at position 0 is, and then numbers I. Since I is starting at 0, it's going to be this first item. So number at position 0 is 4. After that, it will print number at position 1 is 8. Number at position 2 is 21. You guys get the idea? Cool. So using this strategy, we can get the position using I of each value, and then we can get the value using that position, just like we do when getting from an array normally. But we have a fancy new way of doing it. Well, it was new when I learned it. Now it's old, but I guess I'm an old man. But um, let's say we have an array of strings, right? Pen, apple, apple pen, pen, pineapple, if you've seen the video. And this is called a for each loop. So in the past, we had to use the position, right? And start at 0, counting through to the end of the array. But using this type of loop, this is a new type of for loop. You have not seen this before. With this colon operator, this says for each item in our collection, do something. So the colon here makes it a for each loop. The part after the colon is the variable that you're going to go through, the array, basically. And then item is what each value is going to be set to. So in the first run of the loop, item will be pen. When it runs a second time, item will be apple. The third run, item will be apple pen. Okay? So if you only need the values and you don't care about their position, this is easier to write and to understand. And it reads like, for each string item of the PPAP collection, do this. That's how it would read out in English. Okay, questions about this new kind of loop? Cool. So this would print out, I have a pen, I have an apple, I have an apple pen, I have a pen, I have a pineapple, I have a pineapple pen. That's what it would do. Cool. Now, we can also have multi-dimensional arrays. You see 2 sets of square brackets. This would be an array, or rather, this would be an array of strings. Okay, so in this way, we could have an outer array here, and then we could have 2 inner arrays. Okay. Now, in this way, if you're doing something like a game, this is how you could do X and Y, right? You have the 2 dimensions. Or it's just a way to store data in a more complicated format. This can be a little bit difficult to understand at first, especially because right here we're doing a 2-dimensional array, but you can do a lot of dimensions, like theoretical physicist 13-dimension sort of crazy crap, but we're not going to do that here. So in this way, this example is kind of a really crappy poem, but where each item is a word in the poem, and then this first array here is the first line, and the second array here is the second line, and this whole outer array is a collection of all the lines. So this is a semi-practical use of multi-dimensional arrays. So if we wanted to access items in this, we would just do 2 sets of square brackets. So given this right here, who can guess what word this will print out? Almost. It's only going to print out one thing. But your thinking is along the right path. Does anyone else have a guess? Multi-dimensional arrays are hard. So this first square brackets is going to choose which array in the outer array. You know what, maybe I should draw here. So another way, what? I know there's a way to draw. Right click? No? Come on, I did it last week. How do I draw? What? Ah, crap. Sorry, give me a second. I know there's a way to do this. Nope, that's not it. Man, crap. How do I draw? I really need to draw. Okay, maybe I'll just use paint or something. Yeah, okay, screw it. We're gonna use paint. A moment. So, is this? Yeah, cool. So if I have another way to kind of visualize this is like this. If I do first line, typing is hard. I could have just written this whole thing, but whatever. And then second bit in poem. So another way we can look at this, how do I get out of this? Here we go. Is this is 0 for the outer array. And there we go. 0 for the outer array. And then this is 1 for the outer array. And then for the inner array, this is 0 and 1. And this is 0, 1, 2, 3. Oh my God. What is that 3? Okay. So if we're looking for, what happens here is this accesses the position 1 item in the outer array. So that's going to be here because this is the outer array, right? So position 1 is going to be here. And then from there, now we're inside this array. So this part is finished. So now within the next array, we're going to do 0, 1, 2, 3. So 0, 1, 2, 3, and it will print poem. Does that make some sense? Okay, cool. So in this way, you could have more and more and more dimensions, but 2 is usually how many you'll need. If you need more than that, it gets just confusing. Now you'll notice here, these two arrays have different lengths, right? The outer array has a capacity of 2, right? We started it with 2 inner arrays, and we cannot add a third inner array because arrays are fixed length, right? However, the outer array makes no assumptions about how large the inner arrays are. So this inner array can be 2 items, this inner array can be 4 items, however many we want, as long as it doesn't change. Now we could replace it with a new array. We could put a different array in here, but we can't change the existing array. Does that make sense? So basically what I could do is the outer array just can only have 2 items, right? And those 2 items must be another array of strings. But there's no constraint, there's no requirement for how long that inner array can be. So if we wanted, we could remove this and we could create a new array. Let's just write it. We could create a new array with 3 items. Or 4 items, because I can't count. Really? Come on. There we go. Cool. And we can replace this first array with this array. We could do something like, what did I call this? Poem? Poem 0 equals this. And that's fine. That's no problem. Because the outer array does not care how large the inner array is. The inner array can be any size. And so this line here this line here would replace this array of length 2 with this array of length 4. And in that way we can change things. Does that make more sense? Cool. Cool. All right. Go away, paint. All right, so moving forward. So actually one more just to kind of practice. If I wanted to print out let's say this was so that's a 1 and a 3 right now. Let's say I wanted to change it to 0 and 1. What word would be printed out? Yes, correct. And what if John Juan, just for practice, what if I put in 1 and 1? What would be printed? Correct. Cool. Yuhi, do you want to try? I can't hear you, Yuhi. Yuhi, what if we did 1 and 0? What would be printed? You're gonna have to shout it out because you're muted on. Oh, do you just want to go over it later? Okay, we'll go over it later. Language troubles, so we do some extra practice. Okay, so moving forward, she and I will go over it later. Oh, where's my? There it is. Cool. So you guys have an understanding of basic arrays. And we're now going to talk about something completely different. Don't forget what I just told you, but set it aside. We are going to come back to arrays, but for now, we're going to not use them for a minute, okay? Yeah. Yep. Right. Right. Good question. So in this case, the Java compiler will look at the size of this initial array, and it will set the capacity to that. Cool. Good question. Very good question. Any other questions before we go forward? Cool. And I guess just to kind of expand on that a little bit, what happens in this one down here is it basically creates a new array of length 3 because it can just see that there's 3 values here. So it just looks at the number of values and figures it out. That's it. It just saves you some typing. Good question, though. All right, moving forward. So now we're going to move on to inheritance. We're going back to classes, okay? So previously we learned about classes. Classes are like blueprints. Objects are like buildings. Classes can inherit from one another, okay? And I'm going to explain what that is now. When one class inherits from another class, the class doing the inheriting is called the child class or the subclass. Okay, these are just two different names for the same thing. And then the class that is being inherited from, that is the parent class or the superclass. So the child class inherits from the parent class. Okay. Now, the child class has all of the properties and methods, all of the variables and functions that the parent class has. So to make a class inherit from another class, you use the extends keyword. So when you're defining your class, you just say class, the name of your class, and then extends, and what other class you want to inherit it from. Very, very simple to do, but difficult to understand. So if we have a class called car, and it has all these different variables and these different methods here. Sports car will automatically get those, okay? So sports car will have a variable called num wheels. Sports car will also have a variable called color. Now, we didn't define those here. There's no new variables here. But because a sports car extends car or inherits from car, it gets these automatically. It's the same with this constructor and this method. Sports car will get those automatically too, but we're going to change them. So there's some new stuff here, all right, like the super and this override. I'm going to explain what those are in a second. But in addition to extending what the car has, we can add new stuff, right? There's no problem with adding new things on top of what you inherited from your parent. Like that's not a problem at all. So let's what I recommend doing is on your computer, open up this presentation and go to slide 10 because we are going to reuse both of these classes. Okay, so we're going to use this as an example for the rest of the presentation. Any questions before I'm going to explain super and I'm going to explain override, but other than that, any questions before we move forward? Cool. All right. So, and this protected right here. Previously, we learned about access modifiers, but we really only focused on public and private. But there's more. There's 4 access modifiers, right? So public means that any class anywhere can access that property or method. Private means only this class, only within the class can you access the property or method. We talked about those. We did not talk about protected and default. Protected means that if I have another class in any package, and I inherit, if I subclass from this class, if a variable or method is protected, the subclass can use it. So in our example, because num wheels and color are protected, sports car can access them directly. Okay. Now we're not doing that here, but we have allowed that as possible. If we had it as default, basically no access modifier, or as private, and then a sports car tried to access num wheels or color, you would get an error. Okay. So protected allows a child class to use properties and methods from the parent class. Default does not. Default just means other stuff within the same package can do it. Okay, questions about that? Cool. And then I mentioned earlier override. So if we look at our 2 classes, our car class and our sports car class, we have this drive method on our car class, but we're also defining it on our sports car class. Now, we have to tell Java, hey, I know this method already exists. I want to replace it. And that's what this override annotation does. This little at symbol followed by some word, we call that an annotation, which I should probably add to here. And I should probably, cool. Back into presentation. So basically we're going to overwrite the parent class's version. Now, pointer. Now we still want to use the drive method of the parent class. If you want to access something on the parent class, you use the keyword super. So in our constructor here, what we're doing is we're calling cars constructor and just passing in our input to that. So A car can have any number of wheels in any color. However, a sports car, we are making sure that a sports car only has 4 wheels, but then we can take in any color and use that. Okay, so that's what super means in this context. It's as if we just wrote car here, right? And then if we want to use the parent classes or the super classes drive method, we could just do super to get the parent class and then call its drive function. So when we call sports cars drive, it will print I'm driving on some number of wheels, and then it will do this extra behavior as well. So in this way, we can take the behavior that the superclass already does, and we can add more. Questions about super? Or you can also just tell me it doesn't make sense. Can you try that again? Okay, cool. So that covers kind of just the basics of inheritance, the super basics. So now, how and why could we use this, or when should we use this? Basically, you want to use this when you have something that does a little bit of what you want to do already, but you want to do more. And in this way, you can save yourself a lot of work. So let's say I have a car class, right? Or let's say I want to make an application about cars, and I have sports cars, I have trucks, I have sedans, right? There's stuff that all 3 of them are going to do. And they're going to do those 3 things in the same way. And they're going to have the same data. There's just some minor differences between them. So what I could do is I could define this car superclass, and I can have the stuff that's common to all of them, like wheels and color, and I can define that in the car class. And then in my sports car class, I can just inherit from it. In my truck class, I can just inherit from it. In my sedan class, I can just inherit from car. And then I save myself a ton of code. I don't have to write all that stuff again. So that's a kind of practical reason to use inheritance with superclasses and subclasses. But there's also another big reason, and that is polymorphism. Now, a little bit of English stuff here. This is a really strange word, but it has a very specific meaning. Poly, I believe, comes from Latin. It means many, manaio. And then morph, I believe, is also Latin, and it means form or shape. So polymorphism means that it can take on many shapes. It can basically change its shape. So what does this mean in programming? Um, it means that if I have a superclass car, and then I have a subclass like sports car, I already know that a sports car can do everything that a car can do because the sports car inherited from the car. So if I want to use a sports car as a car, I can do that because a sports car can do everything a car can do plus more. So in this way, I can create a car variable, but I can store a sports car in it. Again, because a sports car can do everything a car can do, so Java sees no problem with this. Okay? However, when you do it this way, because Corvette is defined as a car, I can only do methods that are defined on car. I can only do methods and properties that are defined on car. So if I do car.drive, right, that's no problem because car has, if I do Corvette, if I write Corvette.drive, that's no problem because car has a drive method. However, if I try to do Corvette.lookfancy, if you look over here, lookfancy is a sports car method. If I try to do that, it will fail. Now, the variable is of type car, but the object inside of it is really a sports car. But because Java only knows about the variable, it thinks it's a car and it would not recognize the look fancy method. Okay? Because Java thinks it's only a car. So it thinks it can only do the things that a car can do, not a sports car. Um, but what if you want to use something from a sports car? In that case, you can use casting. And I know you're probably thinking, why would I store a sports car as a car? I promise you, I'm going to explain it in a minute. But if you have a sports car and you have it stored in a variable that is a car type, if you want to access something on the sports car, you have to cast it. Casting is converting from one type of data to another type of data. Okay, so I have a car, but I'm going to force it to be a sports car. This is called casting. Now, not all data types can be casted to other types. For example, I cannot cast a car to an integer. That doesn't make sense. How do you represent a car as just a number? That's not possible. If I tried to do that, I would get an error. However, going from superclasses to subclasses, you can do that if the real object is the subclass. So because here we have this car variable, but we're storing a sports car in it, again, if we just call look fancy on it directly, that's not defined on car, so that fails. But if I cast it to a sports car, then it's no problem. This is what casting looks like. You surround, basically Corvette is really a sports car. So if I write in parentheses before it, sports car, that's telling Java, hey, just treat this like a sports car for now. It's okay. And then Java will try to do that. Now I have these extra parentheses here because if I don't have them, if I write just Corvette.lookfancy and then I put the sports car before it, it's going to try to convert the output of look fancy. And that's not what we want. We want to convert the Corvette to a sports car. So we have to put the parentheses here to call look fancy on the converted Corvette, on the casted Corvette. I know that's a lot of information. Does it make sense? Do you have questions? Sure. Yeah, I went through it a little fast. So I wish I could draw. I want to draw, damn it. I know I did it before. Screw it. Okay, paint again. All right, so let's say I have car Corvette, right? And so that's going to create a variable. Variable is like a box, right? And it's going to be called Corvette. And it is in the shape of a car, right? However, a sports car. Here we go. So think of it like this. So a car is like this shape, right? Oh God. You can tell I'm a programmer and not an artist, right? So this is the shape of a car. It is a very long car. So a car and a sports car. I can hear you laughing. Right? They're a similar shape, right? I should probably label these because this is not clear. So I can put a car into here. I can put a sports car into here. They'll both fit, right? Because a sports car can do everything that a car can do, so it's basically the same shape. So it can fit in the same kind of box. Okay, that's the polymorphism part. All right, because a sports car can take the shape of a sports car, or it can take the shape of a car because it inherits from the car. Okay? No problem there. Now, if I want to do from a car, actually, yeah, from a car, if I want to do drive, right, that's no problem. Because on my car class, no, I want to go back. I was going to do that cool GIF thing. So on our car class, we have our drive method, right? So this is no problem. And then on our sports car, we can also do a drive method because a sports car has everything that a car has, right? So that's no problem. We're doing great on time. However, because this box is considered a car, if I try to do this look fancy method, it doesn't like that. Because if you look here, whoa, okay. If you look here at car doesn't have a look fancy method. But we're treating this object like a car. It's a car box, right? The car box doesn't have a button for look fancy. It only has a button for the car things like drive, right? But if a sports car is inside of it, we should still be able to look fancy because a sports car can do that, right? So this is kind of a problem because in reality, there's a sports car in the box, and a sports car can look fancy, but because the box only supports a car, we can't do that. So we can force it to let us do that. If we can I make this bigger? Size big. That's not much bigger, but whatever. If I cast this, now casting is kind of do I want to do that metaphor or will it confuse you? Let's try it. So if I have some mold, right, of a sports car. Oh, geez, doing the same thing again. It's really kind of hard. Yeah, not too bad. All right. What I'm doing is I'm taking the contents of the box and I'm forcing it into the shape of a sports car. And now, because I'm changing its shape, I'm casting it. Casting comes from like, oh geez, this looks terrible. Like casting metal, right? Like if you melt metal and you pour it into a mold, it takes on a new shape. That's where that process is called casting. So that's why this is called casting. So I'm taking what's in here and I'm melting it down and I'm changing it into the shape of a sports car, and then I can do look fancy. So now, if does that part kind of make sense so far? Oh, okay, cool. So to do that in text, this casting part looks like this. That's the casting part. Just that. That does it. So that converts sports car to Corvette. However, if I do something like, come on, yeah. If I do something like this, womp. What Java's going to do is it's going to run this part first. So it's going to run this method. Oh, I have a typo here. Crap. Sorry about that. And it's going to try to take the output of look fancy, and it's going to try to cast that. But look fancy is void. It doesn't output anything. So it's going to try to cast nothing to sports car. That doesn't make sense. So because the order of operations, if you remember kind of math stuff, the order of operations is call the method first and then cast. So again, like math, we can change the order of operations using parentheses. So if we write this, what happens here now is because of these extra parentheses right here, this part happens first. So Corvette gets casted to a sports car, it gets changed to a sports car, and then we call the look fancy method on that object. Does that part make better sense now? Okay, cool. Jonhan, are you okay? Do you understand this? Cool. Yuhi, are you okay? Cool. She said she's okay. All right, so where's my pointer? Okay. Yeah. So that's why we have these extra parentheses here, and that's how casting works. So cool, but why? Why would we do all of this? Why not just have Corvette be a sports car? Why use it as a car? Remember how I told you to forget about arrays for a minute? You can remember them now. Let's say I have a garage. I have a garage of cars. Let's say I have a whole lot of money, which I don't actually, but I wish I did. And I have a collection. I have an array of cars. I have many cars. Maybe they're different kinds of cars, but they're all different kinds of cars, right? They're still cars. So I can have a generic car, I can have a sports car, I can have a sedan, I can have a truck. If you assume that sedan and trucks also inherit from car, because of polymorphism, because all of these inherit from car, so they can do everything a car can do, I can store them in a car array. And that allows me to use multiple types of objects as one type. And then because Java only allows one type of object in an array, it allows me this flexibility because they can all be treated like cars. And then I can just loop through the cars in my garage. And then I can say, hey, if the car is a sports car, look fancy. Otherwise, drive. Because all cars, as long as they inherit from car, any subtype, any subclass of car, like sports car or sedan or whatever, still has this drive method, so I can still use it. And this is where polymorphism gets useful, because I can have some parent type, and I can have any number of child types, and I can still use them like the parent. Now, the new thing here is this instance of. Instance of is a Boolean operator. It checks if this variable is this type of object. So for this one, this would be false because it's just a car. For the second item, this is a sports car, so this would be true, and then this would execute. For the third one, this is a sedan, which is not a sports car, so this will be skipped. The same with the truck. Okay. Any questions about this? Cool. It's actually, whew, I'm some of this stuff is a little difficult to understand, so I'm worried about people not getting it, but so far so good. Yeah, so that's why polymorphism and casting are useful. Except I have a bug here. There we go. Now the reason the reason that we need to do this casting, that we need to check here, is because if we try to cast car to sports car, we're going to get an error. So that's why we have this check first, to prevent an error from happening. Okay. Cool. Moving forward. Remember, because a normal car can't do look fancy, so we have to cast it to a sports car, but we can only cast it to a sports car if it actually is a sports car. Okay. I probably shouldn't have put this here, but that's why this stuff is useful, because this is what makes polymorphism and inheritance and all this sort of stuff cool, because it gives you a lot of flexibility. And I should probably just remove this slide. So given you now understand what polymorphism and inheritance do, now let's look at some actual examples in Java. We're going to go over lists, which is kind of like it's kind of like an array with superpowers. Okay. Now, technically a list is an interface, but I'm going to ask you to ignore that for now. We're going to cover interfaces next week. The important part is that lists are a generic. Okay, that's a major thing I want to teach you with a list. A list is a class, is an object class sort of thing, and it's a generic. Generics are a special type of object. Most of the time, generics contain other objects inside of them, right? So they have variables inside them that have different types. However, when it contains these other objects, for generics, you have to tell it what type of object it will contain. Okay, so it has to be a list of something, a list of integers, a list of cars, and then that list cannot store any other type of object. Okay, similar to an array. So we can if we want to define a new list variable, we can do list, and then these less than, greater than symbols, okay, these define what the generic type is. Okay, so with arrays, we use the square brackets. With lists, we use these less than, greater than symbols. So this is a list that contains strings, and it can only contain strings. Now, lists specifically, you can't create them directly. This doesn't work, and I'm going to explain why in a second. But up to this, does everyone understand kind of what a generic is? Cool. So how is this useful? Well, I'm sorry. So lists are similar to arrays, but there's two major differences. One is that they're an object, right? So they have all sorts of special methods and properties and these kinds of things. Two, and the big thing, is you can resize them. So remember, an array is a fixed size. You can't add items, you can't remove items. But a list, you can add items, you can remove items, you can sort them, all these kinds of things. So the list has all these different kinds of methods that you can use. And I just put a few example methods here. E is the generic type, right? So because in this example, I set the generic type as string. So in this case, it would be string get int index, or index of string element, okay? And these are just kind of method signatures on list objects. So a list object can get, a list object can do index of, a list object can remove, a list object can check if something contains, can check if it contains an object. And then I put a link here to the Java reference if you want to see more. But for example, in an array, if I wanted to see what position an item was at, there's no built-in way to do that. I'd have to go through each item of the array, and I'd have to compare and see if the item matches what I'm looking for. You have to do that manually. You have to write a for loop. You have to do a condition to check, all that kind of stuff. But with a list, you can just call this index of method, and it will tell you the position of the item that you're searching for. Or if you don't care where it is, you just want to see if it exists, you can use this contains method, and it will tell you true, yes, that item is in this list, or false, that item is not in this list. It's much easier than using an array. So any questions about that so far? Cool. So I mentioned that you can't create a list directly. So instead, we use something called an array list. It is a type of list. So list is the superclass, not actually, but we're going to call it that for now. And an array list is a subclass, a child class. Okay. So we just like we did with car and sports car, we can do a list of strings as an array list, just like we did with car and sports car. So and again, you can use array list like an array, just easier. So if we're doing this, why do we need a list? Or why do we need to use list? Why can't we use array list directly? Because there's different kinds of lists. There's array lists, there's linked lists, there's circularly linked lists, there's other lists that I can't think of right now, but there's a bunch. But we're not gonna cover those. We're gonna cover the different kinds of lists in our intermediate series, which will be after we finish the beginner series. So an array list is really just a really fancy array. Okay, and it has all of these methods that a list has. Oh, all of these methods that a list has, because it inherits from list. Any questions? Cool. So arrays and lists, they allow us to store many items of the same type in some order, right? 0, 1, 2, 3, 4. But what if I don't want to worry about the order and I just want to look them up by something like a name? Java lets you do that. There's another data type called a map, okay? And a map has keys and values. You can think of a key as kind of like a lookup. So in lists, if you want to find something, you have to give the position, like 0, 1, 2, 3, mo, 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 mo. But a map, you can say, hey, take this value, and instead of storing it at position 0 or position 1 or position 2, store it at, you can use a string. Store it at the string, crap example, Gangnam-gu, I don't know. And then you could have some neighborhood object stored at that string. And so you can get values in a map by providing the key. You use the key to unlock the door, get the value out of it, right? Maps are changeable and can't be created directly, like lists, right? You can add stuff, you can remove stuff. And they're also generic, right? They use the less than, greater than symbols, except instead of just having one type, they have two types, because you need to specify the type of the string and the type of the value. Okay, so in this map right here, in my smart garage map, the keys are going to be strings and the values are going to be cars. And in this way, I can look up cars by some name rather than by a position. Does that make sense? Cool. So did I not make an example? Okay, I did. Now here's the thing. So lists, they're ordered 0, 1, 2, 3, so on and so forth. Maps are not. They don't have an implied order, okay? So if you try to get everything out of a map, if you do it twice, they may be in a different order, okay? So that's important to remember. And again, lists have all those helpful methods. Maps have helpful methods too. So K is the key type. So in this example here, K is going to be string. And then V is the value type. So in this example here, V is going to be car. Okay, so K is string, V is car. So maps have a get method where if I give it some key, it's going to give me an object of the values type. Or I can put a key and a value. That's how I put stuff into the map. And it'll also give me back the value that I put in as the output. I can remove an object at a key. I can just delete it with the remove method. I can check if the map has some value by doing contains value. And then I can also check if the map is empty. Okay. And as before with list, there's a link to the reference for the methods that a map can do. Any questions so far? Cool. We're doing really good on time. So you can't create a map directly, just like you can't create a list directly. So instead we have something called a hash map. And a hash map is really just the most common type of map. We're not going to go over exactly how a hash map works. It's a bit complicated, too complicated for this class. But they're just a type of map. And setting up a hash map is the same as setting up an array list. It's just another type of map. Again, there are other types of map like tree map and I believe heap map. I'm not entirely sure. But there's all different kinds of maps. Hash map is just one of them. It's the most common kind. I suck for not having examples, so I'm going to add an example real quick because maps are a little more difficult to understand. Actually, let's do. So I apologize for not having this example pre-made because that was poor on my part. Okay, whatever. Cool. What? No. Okay. No. Okay. Sorry, give me just a moment. Crap. I want. There we go. Okay, great. So I can do something like, what's all this empty space? Whoa. There we go. So I can do something like map string car smart garage equals new hash map string car. And then I can do something like smart garage dot put favorite car new sports car, right? Or I can do smart garage dot put commute car and do new sedan, right? And then I could do something like car favorite car equals smart garage dot get favorite car, something like that. Does that make some sense to people? Cool. So in this way, I can store these cars by name, and I can retrieve them by name. And I'll give an example for lists later too. So Junhwan, I apologize for not describing the format of this. Usually we go through a presentation first, and then after that we do some coding together actively. So before we jump into any coding, does anyone have questions about things we've learned so far? Cool. All right. So my friends, open up IntelliJ or some equivalent, and let's do some examples. And this is going to be a little bit rough. I warn you, I did not have a chance to come up with examples. Had too much stuff going on this week. So we're going to do it on the fly. Wait, why am I opening the old version? Whatever, it's fine. I'll uninstall it later. So go ahead and create a new project. Oh, I'm using a really old version of Java, but we're not going to use any of the new stuff anyway, so that's fine. And as usual, just click next. Wait, what? Hold up. No, 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 no. Sorry, don't click next. Select Java at the top. Okay, on the left side here towards the top, select Java. And then do next, next, and then set your project name. So we're going to call it Collections and Inheritance. Okay. Is everyone following along with me, or do you need me to slow down? Okay. Junwan, Yuhi, are you guys okay? Cool. All right, so we're going to finish. All right, so we have our new project. We have our source directory. And now I want to get you guys in the habit of making packages. Okay, so we're going to create a package here. Right-click, New Package. And we're going to call it org.codeseoul.java. Let's start with that. Okay, and you should see something like this on the left side now. Does everyone have their package made? Cool. Then after that, create a new class. We're going to call it our main class. And then you can leave that blank for now. Then after that, we're going to create another package. What are we going to do? What are we going to do? Crap. Nope, that's not a good example. Ooh, that might be a good example. Yeah. Okay. We're gonna make a new package called pen. Pens? Pen? Pens? Whatever. Your choice. I'm gonna call it pen. And then once you've created that package, create a new class, and create a class also called pen, just with a capital P. Okay. So your project should look like this on the left side. Please let me know when you have gotten to this point. Yuhi, do you need help? Do you need help? Okay, let me come check because I couldn't hear you. I'll be back. All right, Yuhi, let me know when you're set up, and I'll come help you get caught up. All right, is everyone, Jonhan and Catherine, are you guys set up to this point? Great. Okay, cool. So let's, how deep do I want to go with this? Not that deep. Okay, cool. So let's do let's so a pen. What we're going to do is we're going to have a pen will have a type of ink. So we're going to do a string with ink color. Okay, and let's just leave it at that for now. And then our pen will have a public constructor, so public pen, and it will take in an ink color as a parameter. And then we're going to set the object's ink color to the given ink color. And then, oh, sorry, and ink color should be protected. Although, yes, technically it doesn't need to, but we'll make it work. And then we're going to have a public method called draw. It's not going to take in any parameters, and it's going to print out I'm drawing with this dot ink color ink. Okay, so oh, whoops, public void draw. Sorry about that. So go ahead and get this typed up, and I'm going to check in with Yuhi real quick because we have to set up some extra stuff for her. So I'll be back to check if you guys are finished. Give me 1 or 2 minutes. Sorry, sweetheart. All right, if your laptop dies, come in here, okay? Okay, sorry about that, folks. Has everyone got this typed up? Catherine, Junhan? Okay, great. Excellent. So now what we're going to do is we're going to create, we're going to create a new class, and we're going to call it ballpoint pen. Okay. I'm gonna split screen here for you. Okay. And actually, hold up. Let's do it this way. Sorry, give me a moment. There we go. And in our ballpoint pen class, we're going to extend pen. And then ballpoint pen will have a constructor that also takes in an ink color. And again, sets this dot ink color, or we can just call our superclasses constructor with ink color. And then following that, let's override. Oh, let's also have our ballpoint pen can have, let's call it a thickness, an integer thickness. And let's also have that be an input. And let's set this dot thickness equals thickness. And then let's have our draw method. Now, because we already have a draw method on the parent, we have to override. And then we can do system.out.println. I'm drawing in this dot ink color, ink with this dot thickness, millimeter thickness. Whoops. I cannot type. There we go. What is this complaining about? Oh, yeah. It doesn't really matter, but let's make this private. Cool. That's fine. All right, so let me know when you guys have this typed up, and let me know if you have any questions while we're typing it. Meanwhile, I'm going to check on Yuhi while you guys are typing. If you ask questions, I can hear you through her speakers, so no problem. All right, you guys got that written out? Are you guys still typing? Great. Okay. Okay, cool. So, should we do one more? Let's do one more, just for fun. Let's do another class, and let's call this fountain pen. And a fountain pen should also extend a pen. Yeah, let's set up our constructor. So fountain pen also takes in an ink color. Or we can again just call the superclass. And then I don't think a fountain pen needs any other special thing for properties, but let's override its draw method. Oh, also fountain pen's constructor should be public. And public void draw. Again, we're going to override. And system.out.println. I'm drawing in ye old style this dot ink color ink. All right, so go ahead and let me know when you guys have finished that. His laptop died. All right, come on in here. 여기에 오세요. 괜찮아? 죄송해. 다음에 찾아. Yeah. It's okay. Do you guys have this written out? Cool. All right, so what we have here is we have pen as our parent class, and then we have two child classes, our ballpoint pen and our fountain pen. All pens can draw, and all pens have an ink color. So this is a pretty good model of object inheritance. But let's do stuff with it. So let's go ahead and go back to our main class. And first off, let's import everything from our pen package. So let's do import org.codeseoul.java, java.pen.star. That will import everything in the pen package. So we don't need to specify each one individually. Okay. And then let's also set up our main function. Oh, dude, come on. Okay. Yes, cool. Pro tip, if you start typing P as in public, static is in, or S is in static, V is in void, M is in main, IntelliJ will help you autocomplete, which is kind of nice. But that's why you have to memorize public, static, void, main, string, args. Otherwise, that doesn't work, right? And then let's which way should we do this? Let's create a list of pens, and let's call it a pen collection. Also, here's a thing too. Let's say that you want to use a type, like a list. A list is not available by default. We have to import it, much like we imported our pens. So if you start typing it, IntelliJ is going to be like, dude, I don't know what a list is. Lists aren't available by default. If you do that, and then you click over here, and you hit Alt Enter or maybe Command Enter on Mac, I forget exactly. Maybe it's Control Enter. It gives you the option to import the class. You don't have to remember which package it's in. You can just say, hey IntelliJ, just import this for me. And IntelliJ knows that it's in this Java util package, so it'll figure that out for you. So then, for our pen collection, let's create a new array list. And when you'll notice when I start typing array and I do list, if I select it from autocomplete here, right? Like if I go through these and I pick one, IntelliJ will automatically import it for me. So I don't have to memorize which package it's in. I just need to know it exists. And IntelliJ can do the work of finding the correct package. Now here's the thing too. In the slides, you have the generic type here. You don't need to do it on this side. Java will see it here and be like, okay, I know this array list is supposed to hold a pen. You don't need to tell me. I can figure it out. Okay. Questions about this so far? Cool. So now let's go ahead and add some pens to our collection. So let's do pen collection and add. Now here's a cool thing. You'll notice here, IntelliJ recognizes that whatever we're adding is supposed to be a pen, right? Because we defined the generic here. So Java/IntelliJ is smart enough to go, hey, I know that you need to put a pen in here, so give me a pen or I'm going to tell you there's going to be an error. So we can do new, let's make a new ballpoint pen. And it needs a color. Let's make it a black ballpoint pen. Oh no. Oh, oops. Right, ballpoint, we need to give it black and we need to tell it the width. Let's do, what is it? 3.5 millimeter, I think is standard. Oh, sorry guys, I messed up. Let's just say it's 3 millimeters because it's an integer, not a float. What are you complaining about? Oh, I apologize. I made a mistake in ballpoint pen. We have to make this constructor public. Otherwise, main can't see it because main is in a different package. Main is not inside the pen package. So if we don't make it public, main cannot see it. So don't forget to make that change here. Sorry about that. What are you complaining about? So in ballpoint pen, I forgot to make the ballpoint pen constructor public. Because it was not public, the main class could not access it. It was an access modifier bug. So I added public to the ballpoint pen constructor. Sorry about that, my mistake. You know, let's check fountain pen and pen. Okay, these look fine, so we're good there. And then let's also add our, let's also add a fountain pen. And let's give it a blue ink because we're going to be fancy. So far, so good? Okay. Ah, crap, I can see that. Let me know when you guys have this written up. Cool. John Juan, are you okay? Oh, you're still doing it? Okay, I'll wait. Let me know when you finished. John Juan, do you need help or are you okay typing things up? Okay. Are you finished or do you need more time? Oh, okay, great. So now let's go ahead and loop through our pen collection. Let's for pen current pen in our pen collection, let's do current pen.draw. And so once you guys have written this up, go ahead and just, you can just right click and say run main.main. And after a minute, there you go. Does anyone have trouble getting this running? Great. Catherine, are you okay? Okay. Cool. Good job. Now, Catherine, do you want to explain the error that you had just so that we can all learn from it? Or if you don't want to, that's okay too. Oh, that will happen often. That will happen very often. Cool. All right. So, who wants to explain how and why this is working? Or do you just want me to explain it? Okay. So I'll give it a shot then, or do you just want me to give you the vocabulary as you're explaining? Okay, no problem. So here we create a list of pens. Okay. Now, because what this really means is that we have a list of pens and anything that can act like a pen, or basically any subclass of pen. And we're going to create a new variable to store this list called pen collection. And then we're going to create an array list, because an array list is just another type of list. So that creates an empty array list. And then we're going to add some items to this pen collection list. Okay. We're going to add two new pens, right? And they're going to be our ballpoint pen and our fountain pen. Now, the reason that we can store these as pens, actually, hold up. How do I get rid of, disable hints. There we go. Sorry, for people who are watching this recording later, if you saw that extra text here, IntelliJ adds that to make it clearer for the programmer's memory of what the different parameters are. I did not actually type those. What I did just now removed that. So you want to type this, and then IntelliJ will make it look a little bit different, but this is what you should actually type. So for people who are joining on the recording later, I apologize for any confusion. Your code should look like this. So going back to explaining what's happening, ballpoint pen, if we look at it, it extends pen. So we can use a ballpoint pen as a pen due to polymorphism, many shapes. A ballpoint pen can take the shape of a pen because it can do everything a pen can do. And the same with fountain pen. Fountain pen also extends pen. It can do everything a pen can do, so it can take the shape of a pen using polymorphism. And because these can both take the shape of a pen, we can store them in our pen collection. Questions about that? Cool. And then we use a for each loop to go through each pen in our pen collection. And because our normal pen has a draw function, any subclass of pen will also have a draw function. So we can just call their draw functions. And the ballpoint pen will print out, I'm printing in color ink with number millimeters thickness. And so, because a ballpoint pen is the first pen in our collection, the first thing that's printed is I'm drawing in black ink with 3 millimeter thickness. And then because our fountain pen is our second item in the collection, in our list, based on what a fountain pen says it does when it draws, it's going to say, I'm drawing in ye old style color ink. So I'm drawing in ye old style blue ink because we created it with property blue. Does that make sense? Do you guys have any questions? Cool. John Juan, are you okay? Cool. Yuhi, are you okay? Cool. All right, so that's an example of inheritance, polymorphism, and lists. Oh, we have a little bit of extra time. So let's do a quick map example. Let's do a map of string to pen. And I'm going to do this one a little bit quickly. Again, remember we have to import, and I don't know what it is off the top of my head. So after I've typed out map string pen, IntelliJ is like, hey, do you need me to import this? And on Mac, it should tell you the shortcut here. But on Windows, it also tells me here. So I just do Alt-Enter. And I want to import map from Java util. So I select that. It does it for me. And I'm going to call it smart pen collection equals new hash map, which I will also need to import, but it will do it automatically. And then for our smart pen collection, I'm going to put fancy pen. It doesn't. I'm going to yeah. I'm going to put the from my pen collection get the first item or the second item, so index 1, and then smart pen collection dot put my work pen as pen collection dot get the first object, which is going to be that. And then lastly, I can do something like smart pen collection dot get fancy pen dot draw. You'll notice here I'm not storing it in a variable, but we'll talk about that in a minute. So try this, try running it, and then we can talk about what it's doing and how it works. Now I really want to try my new fountain pen. Just let me know when you guys have finished typing and you've gotten it working. Otherwise, I'm just going to be waiting, okay? Catherine, are you still typing? Okay. Okay, no problem. Take your time. I just wanted to make sure that I didn't miss your speaking or anything. Okay, great. And have you guys tried running it? Does it work? Okay, great. Okay, great. So, who wants to try and explain how this works? Or should I explain? Okay. All right. So, here, similar to what we did with our array list, we're creating a generic type of map. Our keys are going to be strings and our values are going to be pens. And we're going to create a hash map to store in this map variable. And then following that, it's going to be empty, so we have to put stuff into it. So map has this function called put, and that allows you to put some value at some key. So we're specifying the key as fancy pen, and we're specifying the value as the pen at position 1 in our array list, which is actually the second pen, because remember, we start counting at 0 in programming. So we're putting the fountain pen as the fancy pen in our smart pen collection. And also in our smart pen collection, we're going to put our work pen as the ballpoint pen, because we're getting the 0th item, or the item at position 0, in our pen collection. And that's going to be the first item we added, which is a ballpoint pen. So following that, we're going to get the fancy pen from that collection. And now here's kind of a new thing. In the past, anytime we've tried to get a value, we've stored it in a variable, but you do not always need to. So what we did here is this right here, when this part runs, when this part evaluates, the value in the map takes this position. It replaces whatever is here. So at this point, the fountain pen is here. So then all the stuff that a fountain pen can do after this point here where my cursor is, we can use everything that the fountain point has. So we're just going to use the draw function on the fountain pen without needing to store it into a variable. We could also write this right. These sets of lines here are functionally the same, except that in this case we're storing the fancy pen into a variable my fountain pen. But since we're not going to use my fountain pen again, we can just call it from the collection. We can just call it from the map directly. Okay, so these are functionally the same. Okay, does that make sense? Any questions? Cool. So that concludes all the material I wanted to cover today. From anything that we talked about today, do you guys have any questions about stuff? Yeah, this kind of stuff, like when you hear it the first time, you're like, oh yeah, that makes sense. But if you don't look at it again, you're gonna lose all of it. So yeah, good point, Catherine. Um, so yeah, given that homework, um, yeah, this one's complicated. Um, but it's pretty much it's very similar to what we did just now. It's pretty much the same thing, just it's actually less than what we did just now. This is a lot of steps here, but I tried to write them in a manner to make them as basic and simple as possible. This is the same thing as what we did just now. It's just we added a getter and we're not using an array list and a list. We're only doing map. So beyond that, it's the same as what we did today. So as usual, I recommend that sometime in the middle of the week, maybe like Wednesday or Thursday, do this homework to kind of refresh your memory. And that way, next week, you should have a better memory of what we did. As usual, I have added additional resources. So if you go through these slides later and you feel like, oh man, I don't understand what's written here, or if you feel like you need things explained in a different way, here are links on the various topics that we covered today. So we arrays, inheritance, polymorphism, lists and array lists, maps and hash maps, these kinds of things. And then I will add the code that we wrote today and the video once I complete them. And as usual, thank you guys for coming. Again, we are a nonprofit organization and we do run on donations. Your phone. So if you want to donate to us, that would be awesome, but you do not need to. Right now, our donations are not tax deductible because we are still a phase 1 nonprofit in Korea, and you cannot get tax deductible status until you are phase 2. So there is no tax benefit to donating to us now, but if you want to, you can. But yeah, beyond that, thank you guys for coming. As always, if you have questions or problems, you can always join us on Discord and ask. Anything else before we finish today's lesson? Cool, no worries. Thank you. And I'm going to stop the recording now.